In this video, we're going to solve the following linear programming problem. Let's suppose that a transport company has two types of truck. We're going to call them type A and type B. Let's suppose that type A has a refrigerated capacity of 20 meters cubed and a non-refrigerated capacity of 40 meters cubed. Truck B has the same overall volume, so 60 cubic meters, but equal sections of the refrigerated versus non-refrigerated. So that means we should have 30 meters cubed for both. A grocer now needs to hire some trucks for the transport of 3,000 meters cubed of refrigerated stock and 4,000 meters cubed of non-refrigerated stock. This sentence is going to lead to our first two constraints. If I take the capacity of the refrigerated stock of each truck, so for example, if I say 20 cubic meters for truck A and 30 cubic meters for truck B, I need to make sure that I get at least 3,000 meters cubed of the refrigerated stock. So I need this to be at least 3,000. I could have a little bit of unused space, but I want it to be at least 3,000. Similarly, for the non-refrigerated stock, we can take 40, multiply it by the number of truck A's, and we can take 30, multiply it by the number of truck B's. I need this value to be at least 4,000. Next, let's take a look at the cost per kilometer for our trucks. So the cost per kilometer for type A, let's say, is $30 per kilometer, and for type B, let's say it's $40 per kilometer. The question is, how many trucks of each type should the grocer rent to achieve the minimum total cost? And this is going to lead us to the equation that we're trying to minimize. So our minimization equation is going to be P is equal to 30A plus 40B. And we're going to have the following two constraints. Plus, we probably should also add in that trucks A and B should be positive numbers as well. Now that we've formulated our linear programming problem, let's go ahead and try to plot our constraint lines. So I'm going to change the inequalities to an equal sign so that I can easily solve for these lines. I want to get a rough idea of where they are in the AB plane. Easiest way to do this is to assume that one of our variables is equal to 0. So for example, let's take A is equal to 0 first, and then if we divide both sides by 30, we get 100. So I'm going to go ahead and mark along the B-axis 0, 100. And then we come back, we'll repeat the same thing for B. We'll assume that B is equal to 0. And then to solve for A, we'll divide both sides by 20. This gives 150, so I want to scan along the A-axis and plot a point at 150, 0. Then we're going to go ahead and we are going to connect these two intercepts. And let's start repeating the procedure for our second constraint. For 40A plus 30B is equal to 4,000, let's go ahead and assume A is equal to 0, and then we will divide both sides by 30. This gives B is equal to 133.33, so a little bit higher than what we had for our black line. So I'm going to go ahead and plot this in green. And then we'll come back, we'll do the same thing for variable B. Let's assume that variable B is equal to 0, and then we can divide both sides by 40 to get 100. I want to come along the A-axis here and plot 100, 0. All right, and let's zoom in and connect those two dots together to form our second constraint line. Next, we want to figure out where the feasible region is. And we can do this by understanding the inequality direction. So because both of the inequalities in our constraints are greater thans, this means that we're going to be looking to the right of both of our lines. So I'm going to go ahead and start highlighting along the lines here that are going to be the boundary of our feasible region. Okay, so our feasible region is everything up here. Lastly, we know that the optimal solution to our problem should lie at one of our corner points. In our feasible region, we have 3 corner points. We have one here, and one here. We already know the coordinate pairs for 2 of these corner points, so the last thing we need to do is figure out the ordered pair for this corner point. All right, so zooming out, we know that this is the intersection point of our 2 constraint lines. So let's grab those 2 lines. 20a plus 30b is equal to 3,000. And 40a plus 30b is equal to 4,000. And let's use the elimination method in order to get rid of the variable b inside of this linear system. So 40, take away 20, that's going to give us 20a. Of course, 30 minus 30 gives us 0. And 4,000 minus 3,000 is going to give us 1,000. Let's go ahead and divide both sides by 20. And we get that a is equal to 50. If we know that a is equal to 50, we can sub that into our first equation. Let's say 20 times 50 plus 30b is equal to 3,000. We know 20 times 50 is equal to 1,000. So let's go ahead, let's subtract 1,000 from both sides. That's going to give us 30b is equal to 2,000. And dividing both sides by 30 gives us b is equal to 66.67. So now we have the last ordered pair that we need. That is 50, 66.67. So these are the 3 corner points we're going to put into our minimization equation. And we're going to see which one leads to the minimum for us. All right, so recall that we're trying to minimize 30a plus 40b. The easiest way to find the minimum is to sub our ordered pairs into our function for p and see what happens. So if a was equal to 150, p would be equal to 30 times 150 plus 40 times 0. And 30 times 150 is 4,500. So this is going to be how much it costs us to rent 150 of truck A. Next up, I'm going to slide the corner point at 0, 133.33 up a little bit because we need to hire at least 134 truck Bs. We can't hire a third of a truck. So let's just alter this corner point slightly so that we are going to substitute 0 and 134 into P. So if we do this, we're going to get 30 times 0 plus 40 times 134. And performing this multiplication, we get 5,360. So since this is a little bit higher than our initial corner point of 150 and 0, this is definitely not going to be the minimal solution. So we have one more point to try. That is the point at 50, and we're going to slide this up to 67. And let's go ahead and perform this multiplication. So we need 30 times 50 plus 40 times 67. And simplifying this expression, we get 4,180. That is a little bit cheaper than the first option, which was to hire 150 truck A's, and leads us to our conclusion that it's best for us to hire 50 truck A's and 67 truck B's.